Hello and welcome back to the lecture on applied econometrics. We have been talking about model specification, and specifically we are talking about omitted variable bias. So there are at least two types of model specification we have talked about: to get the right variable, and second is to measure the value of the variable. Okay. Now we have been talking about the first problem, to get the right variable, and the first part of that first problem is the problem of omitted variable bias. So where we actually exclude a relevant variable and what happens there, right? So when you're talking about omitted variable bias, just to recap, we said that it actually influences my y variable of interest, the dependent variable, through two routes. One is through error term, and second is through the other variable present in the model. Okay, and we already talked about this one. This is essentially the problem of heteroscedasticity and autocorrelation, which we have explained in detail previously. Now we will talk about this particular problem. Okay. This particular problem when x3 is actually influencing y through the root of x2. Now before I do that, let me actually explain the problem of omitted variable bias a little bit in detail so that you understand the relationship with the true model and the fitted model in case of omitted variable bias. And this is something I have taken from Christopher Dougherty: true model, and here a fitted model. Let's say my fitted model, let's say first let me write down the true model. Okay. So let's say the true model is y is equal to, let's say, beta 1 plus beta 2 x2 plus beta 3 x3 plus some u. Okay. And in the second case, y is equal to beta 1 plus b, let me actually reduce the size a little bit, plus beta 2 x2 plus error term. Okay. Let's say I have fitted a model, and that model, let me use a different color for fitted model. Let's say this is y is equal to beta 1 plus, so I have this, or I would rather write, so in case I am fitting a model, so I write b instead of beta, right, because I am estimating that. Beta 1 b1 plus b2 x2, and I don't have an error term here, and y, let's say this is the one case I got this model, and the other case I got this model, b2 x2 and b3 x3. Okay. So if these are the possibilities, so if this is a true model, and let's say two students have got two different fitted models, so this is fitted model 1 and fitted model 2. Okay. So if this is what we get, so then in this case what I am getting, I actually have omitted an important variable, which is x3. I did not include x3 in my model. So this is a problem of omitted variable bias. Omitted variable bias. Or let me use a different color. This is a problem of omitted variable bias. Okay. Whereas this one, if the student has actually fitted model B, this B1 and B2 x2 and B3 x3, whereas the true model is this, so then this is a true model. Okay. So I will write this is a correct fit. Okay. We have got the right model. On the other hand, if let us say the true model is this, actually y is only explained by x2 and there is no x3 component present, and the student has actually got the model, he actually got b1 plus b2 x2. So exactly he has only one explanatory variable, which is x2. So in this case the model is true model. Here the model fitting is correct. On the other hand, if this is the true model and a student has actually ended up fitting this model, so he has actually included this component which was irrelevant. So this is a case of where inclusion of irrelevant variable. Okay. Inclusion of irrelevant variable. Okay. So these are the two problems that we see when we are talking about model specification and when particularly talking about inclusion or exclusion of a particular variable of interest. So we are talking only this one right now. So this is something we will talk about later, and within omitted variable bias we are talking about error root, u root and x root. Okay. So let's now, we have explained the u root, let's now talk about the x root. Okay. When y is getting influenced by x2, whereas x3 is omitted. So, x3 is actually influencing y through x2. Okay. So, that is a problem that we will talk about. Now, let me actually draw another diagram to sort of illustrate it even in a better way. Let us say this is my y, all right, this is my variable of interest, and this is my x2 and this is my x3. So, how exactly I can draw it? So, x3 is influencing y, x2 is influencing y directly, and then there is a direct influence of x3 on y2. Okay. But because I am not having x3 in the model, so what is happening is that this x2 is actually mimicking the effect of x3, and that is being present in the y model. So, whereas this particular component is actually absent. Okay. So, this is how we can actually explain the influence of this is actually how we can influence the basically try to understand the problem of omitted variable here. So, let me actually explain mathematically. So, this is a graphical illustration. We have sort of got an intuitive understanding, and this is sort of a graphical understanding, and let us now talk about the mathematical illustration of it. So, let us say in this, so our true model is y is equal to beta 1 plus beta 2 x2 plus beta 3 x3 and u, and fitted model is y hat is equal to b1 plus b2 x2. Okay. So, essentially I have omitted this variable. All right. So, let us now try to understand what is happening to my regression coefficient. Okay. So, what beta 2 is actually representing here, how much it is able to explain and what component. Okay. So, let us try to sort of get that. So, we know by definition B2 is equal to, we know the definition of the coefficient. So, that is basically x2 I minus x2 bar into y2 yi minus y bar, and then in denominator I have x2 I minus x2 bar whole square. Okay. So, that is how we actually estimate coefficient in a simple OLS. This is a simple OLS. Now, let us sort of substitute the value of yi and y bar from the real model. Okay. So, then it will be is equal to x2 I minus x2 bar into yi is going to be, so I am going to get the value from this model. So, which is essentially, your this component is going to go vanished, beta 2 into x2 I beta 3 x3 I plus ui minus beta 2 x2 bar minus beta 3 x3 bar minus u bar. Okay. So, that is what you have in your numerator, and denominator is going to be the same, that is x2 I minus x2 bar whole square. Okay. So, it has become pretty lengthy, I mean a little daunting also, but nothing to be sort of it is actually very simple here. So, let us actually sort of get the terms separately. I wish we could do it in the same page. Let us see. So, if we can, let us say I take x2 I minus x2 bar, and then here I have, let us say there is a beta x2 I and there is a beta 2 x2 I and beta 2 x2 bar. So, I can take this beta 2 here and I can have an x2 I minus x2 bar, and then I will have another term, that is beta 3. So, here for x3 I and x3 bar. So, if I take this, so that will be x2 I minus x2 bar into beta 3, and then I have x3 I minus x3 bar. Okay, it's really getting a little cluttered, but let's see. And then I have this ui and u bar. Okay, So, all I have is x2I minus x2 bar into ui minus u bar. Okay. And for all the terms, I actually divide by this denominator. So, it will see what I get from here. So, let me actually use this space of this page. So, let me actually write it. So, here I have, you see, this term and this term actually results into this term, and all you are left with is beta 2. So, you have a beta 2. Then in this term you again get this term and this term. So, x2I x2 bar into x3I x3 bar with a beta 3, but the denominator is different. Okay. So, what you get is this beta 3 into summation x2I x2 bar into x3I minus x3 bar by summation of x2I minus x2 bar. Okay. And the third term is x2I minus x2 bar into ui minus u2 bar, and then you have the same denominator here, x2I minus x bar. Okay. Really cluttered, but let us try to make sense from here. I did not want to go to the next page because then I had to copy all these things from this page. So, if I actually see, so I have a beta 2 here and I have a beta 3 into some component. Okay. And if we look at it carefully, so it is basically talking about the correlation coefficient between x2 and x3. Okay. So, you see that I am basically measuring the covariance in the numerator. I am basically measuring the covariance. This is the covariance between u2 and u3, whereas this is the covariance that I am getting between x2 and the error term. Okay. Now, this is, you remember, our assumption is a non-stochastic regressor, and this, because it is a non-stochastic regressor, this term, if I take an expectation of this is going to be 0. Okay. Because these are the deterministic component, these are already fixed. So, this is going to this, if the coefficients are already fixed, they cannot have any correlation with the error terms. But this term here, this is something else. We need to sort of consider that carefully. It is a correlation coefficient between x2 and x3. Now, when we have a correlation coefficient between x2 and x3, let me actually take a new page, and that is, let me write down what we got previously. So, beta 2 plus beta 3 x2I minus x2 bar into x3I minus x3 bar, and in denominator I had x2I minus x2 bar square. Okay. So, and the third term was 0. Now, this was supposed to be the true sort of, we are getting beta, we are estimating B2, right. So, B2 should be, I mean B2 should result in beta 2 if I take expectation. So, we should get, so from this equation we should get the value of B2 should, ideally it should represent beta 2, but then we are getting additional component of beta 3 into this term, and this is this is actually talking about, this is effectively representing the bias. So, this part is a bias in the model when I get this whole beta 3 into this term. Okay. So, what is the quantity of this bias? So, let us say if I have let us say if I have x3, x3 is equal to, let me write down, a plus let us say h x2. So, then this correlation coefficient between the value of h is going to be this, because this is the correlation coefficient between x3 and x2, and it is going to be x2I x2 bar into x3I x3 bar by square of x2I x2 bar whole square. Okay. So, this is the essentially this is the correlation coefficient, or this is the basically, this is basically the coefficient of x2 when I regress do the regression between x2 and x3. Okay. So, this is h, and then if I sort of take the value, impute the value of h into the previous equation, it will be beta 2 plus beta 3 into h. So, this beta 3 into h is going to be the bias term. So, we need to sort of understand this bias term. So, the extent of the bias in a regression equation from this value. So, essentially you see there are two components here. One is a beta 3. So, beta 3 is nothing but the actual strength that basically represents the actual strength of relationship between x3 and our y term. Okay, the beta 3 is actually representing that, whereas h is representing the strength of relationship between x2 and x3. So, we will see in the next lecture how this relationship, the strength of relationship and the direction of relationship between x2 and x3 and between x3 and y is actually sort of will help us to understand the extent of bias in the regression equation. Thank you.